Hi guys, welcome to the last video, which is just I want to work through a couple of the most common queries that I got from you guys regarding questions from test 2, and that's looking at the response to selection stuff in question 9 and the correlated response to selection in question 10. Okay. So for question 9, it was actually relatively simple, but people didn't really apply their understanding of the question. So I'm just going to show you how simple it is. And so the question reads, most of you should have your scripts. 5 generations of selection for decreased plasma cholesterol level in liver of rabbits decreased the mean from 2.16 to 2.01, and remember this was in 5 generations. Okay. The average selection differential was 0.07. What is the realized heritability? So most of you guys know the formula. The response to selection is equal to the heritability times by the selection differential. So in this case, this is our response to selection, which, by the way, was seen over 5 generations. What people don't realize, or at least they don't think of it immediately, is that this formula is the response to selection over one generation. One generation of selection. Now in this question they're talking about 5 of generations. So over 5 generations there was a decrease in selection, so it's a negative value of 0.15. Okay, you can calculate that by minusing the smaller from the larger. Okay, and it's a negative value because it decreased. But this happened over 5 generations. So in order to work out the average response to selection per generation, we're going to divide by the number of generations, which is 5. So we should get a negative 0.03 value. And that is now our R value. Okay, given that our average selection differential over the generations was 0.07, we just substitute into the formula. So it would be an R value of negative 0.03 is equal to our H squared value, which we will calculate, times by our selection differential, which is 0.07, and you just solve for H squared. Very, very simple, but some people still didn't quite understand the logic behind it. So it is. Excuse the scribble. I realized I did the wrong information for this question C. So I'll just redo it again. So question C asks how many generations of selection with a selection differential of 10 would be required to increase the average number of eggs laid per individual from 180 to 220, given a narrow sense heritability of 0.2. Okay, so we want to find out how many generations will get us from 180 to 220. So we want to see, first of all, what our response to selection per generation is. So we want to know what R is per generation before we can find out the number of generations. So that's relatively easy. We take our R, which is equal to 0.2 times 10, which gives us 2 eggs per generation. Now this wants an increase of 40 eggs, but we can only do 2 eggs per generation. So how many generations will that take? That will take 40 divided by 2, which is 20 generations. And that's all it is. Okay, now for question 10, this confused a lot of people, and I think for the most part, sorry, I'm going to just put a new page. Most people didn't understand this because they don't understand the components of the question. Sorry, correlation due to selection. Correlated response, okay. Sorry, not selection, selection. Okay, so the question asks, sorry, let me get it out. The question asks that suppose we are selecting dairy bulls for improving milk yield using progeny testing, and we are using the top 5% of bulls with an average accuracy of 90. What is the expected genetic change in fat percentage given that the genetic correlation between milk yield and fat percentage is negative 0.45, the heritability of fat percentage is 0.5, and the phenotypic variance for fat percentage is 0.8. Suppose also that the generation interval is 5 years, and it gives us the selection intensity of 2.06. Okay, so I haven't written all that down right now because the first thing we need to understand is the kind of question we're dealing with. And this is the correlated response to selection. So, okay. And we should know by now that that can be calculated by two formulas. So it's delta G X when selecting for, Y when selecting for X. So this is saying the change in value, okay, in Y value according to how we select for with X. Okay, that's what this funny symbol means, alright. And it can be calculated in two ways, using the correlated response between the two, between X and Y, the accuracy in predicting X values in the next generation, the selection intensity, and then the additive genetic standard deviation for trait Y. Okay, all over our generation interval. And the other way it can be calculated, see, same symbol, same value, is again using the correlated genetic response, RG, our square root of our narrow sensitivity for trait X, the same for narrow sensitivity of trait Y, our selection intensity, and our standard deviation of our phenotypic values, so our P for trait Y, okay, over our generation interval. So in this question, we know that we are looking at two traits. The first trait, the trait that we are using to select with, is milk yield, okay? So we're going to let X refer to the milk yield. And we want to see how selecting for milk yield changes the fat percentage, which we will denote with Y, okay? So let X be milk yield, and let Y be our fat percentage, okay? So now we can go, now that we've defined what we want from our question, let's go back and see what we have been given. So using the top 5% of bulls, that's how they are selecting. Now, just so that you don't get confused, in your notes there's a selection intensity table, which tells us that when we use 5% of the total population, we'll have a selection intensity of 2.06. And in fact, this question already gives us that value. Okay, so don't be worried that you've left out something. When you come across that section and you realize that you left out that value in your original calculations, it's fine. It was already accounted for by your selection intensity. Okay, then it tells us with an average accuracy of 0.9. Accuracy in predicting traits in predicting values in the next generation is our RAIX, and that was given to us as 0.9 or 0.9090%. Okay. Then it gives us the genetic correlation between milk yield and fat percentage, which is our RG, is equal to negative 0.45. So it has a negative correlation, which is nothing special. It just tells us that the lower the milk yield, the higher the fat percentage, and vice versa. Okay, it tells us the heritability for fat is the heritability for fat percentage, which is Y, is equal to 0.5. And the phenotypic variance value for fat percentage, which is our this value, phenotypic variance, phenotypic variance for fat percentage, which is Y. Remember, because it's variance, it's squared, then we're going to have that value is our 0.8. And it gives us a generation interval of 5 years. Okay. Right, so what do we have so far? We have our selection intensity, because this also tells us how we're going to, which formula we're going to use to calculate this question. So we have our selection intensity, we have our RIAX value, we have our correlation coefficient values, we have our narrow sense heritability for trait Y, we have our phenotypic variance for Y, and we have our generation interval. So for both questions we're missing pieces. We're missing that one and we're missing that one. Now don't worry, that might seem confusing and scary, but you just need to use clever maths to figure this last bit out. Right, sorry, excuse the this other squiggle. Right, so we're worried about what we do and don't have in this next, to what we're going to use for the next equation. So for now, I'm going to say ignore this bottom equation, we're going to use the top equation, and I'll show you why now. Okay, so what we want to look for then is our additive variance from for our fat percentage. What else in terms of variance do we have from fat percentage? Considering that we already know that the narrow sense heritability is equal to VA over VP. Well, have a look at this. We've got our VP value, and we've also got our narrow sense heritability. Isn't that convenient? So with that, we can calculate our variance for our VA, right? Okay, so that's pretty simple. We're going to substitute into the formula here. If our VA, what would it be? Yeah, sorry. It would be our VP value, which is given to us. Remember, the question gave it to us as phenotypic variance, not standard deviation, which is asked in the question, but phenotypic variance, which is 0.8 times our narrow sense heritability, which is given to us as 0.5. And that should give us a VA value of 0.4, right? Yes, okay. So, After doing that, we know that we need to look for the standard deviation, not the variance. So in order to get the standard deviation of our additive genetic component for fat percentage, we're going to square root 0.4, and that gives us 0.632. Okay. Now, for the rest of our equation, actually no, that's all we need, because the rest was given to us in the other formula. So now we have everything that we need for this formula here. So let's substitute. We've got for our delta g, y, x, we have our RG value of negative 0.45, our accuracy value of 0.9, our selection intensity of 2.06 as given by the question, and also if you calculate it, or not calculate it, if you look it up on the selection intensity table, and our standard deviation of our additive genetic component, which is 0.632, all over our generation interval, which is 5. And that should give us a value of negative 0.104. And that's what your answer will be. Now, for those of you who are interested, not that I think many of you will be at this point, this means that our correlated response to selection will cause a decrease of 0.104 in fat percentage if we select for milk in the previously mentioned manner using the top 5% of bulls. Okay, thanks guys, I really hope that helps. This is the last of the videos, and I really hope this helps with your exams. If it does, if you're happy with what I've done, please leave a like on these videos if they are posted up to YouTube, because there's the tiny chance that I'll get a ridiculously small amount of revenue from it. If not, don't worry about it. And thanks guys, I really hope you have a good exam, good luck, all the best.